Hey guys, today we're going to do 110. Sorry you have to listen to this, but this is an easy lesson. Most of it's review, so hopefully a lot of you will be able to kind of work through this quicker than if we were in class. So we're talking about slope. Slope is abbreviated M. You know it's your rise over your run. Your change in X over change in Y, that's what that delta means. It means change in, it's the Greek letter delta. Change in Y over change in X, change in Y over change in X. Sorry about that. And the change in y is y2 minus y1, change in x is x2 minus x1. So what's highlighted in yellow is really the formula m equals y2 minus y1 over x2 minus x1. Depending on the context, slope is called slope. If I have like a ramp, it can be called pitch, the pitch of your roof. It can be called grade, the grade of the road, and all of those are mean the same thing. It just kind of depends on the application. A few reminders, slope of a vertical line is undefined. There is no slope. Horizontal line is 0. And you have your positives and negatives. I'm going to change this. Instead of none, I don't want you to be confused with 0. It's undefined. So it does not exist. Opposed to a horizontal, the way I remember it is there's an O in horizontal and there's an O in 0. So horizontal or the 0 itself, horizontal has a 0 slope. Okay, so we need to find a slope. If you need to, you can label x1, y1, x2, y2, and you're going to calculate using the formula, which you will need to have memorized for me. Hopefully you already do. And that is never an acceptable answer. You always have to reduce. As well, you should never, well, unless it's a context problem application, your slope should always be in a fraction form. That way we can see the rise and the run. Okay, so that was a review on slope. Here's your point slope form. When you finish your point slope form, it might look something like this. So you're still going to have your x and your y there. It's the x1, y1 is the point, whatever point you know, and then of course n is your slope. So it says find an equation of the line through this point with the slope. I'll tell you, if it doesn't tell you which way to put it in, you can put it in any form. The back of the book might say something different. Normally, I prefer you to put it in slope intercept, y equals mx plus b, and solve for y. But if it doesn't tell you, I'm fine with you doing it anyway. Just know when you check in the back of the book, it might not match up if you have it in a different form. So I know my slope, I know my point, so y1 is a negative 3, my slope, and then minus 1. So that's it. I finished part A. That's in point slope form. Later we'll do slope intercept, which is what you're used to, which is solving for y. So if you wanted to do that, which like I said, at some point you'll need to, this is mostly what I'll make you do. I distributed my negative 1/2, and then I'm going to subtract 3 over. And so 1/2 minus 3 is negative 2/2, negative 2.5, something like that. Any of that's fine. And then it says to graph the line. Well, the easiest thing, you can graph this. You should remember this is your y-intercept. This is your slope, your rise, and your run. But I know my point, so I'm going to start at 1, negative 3. And I know it has a slope of negative 1 over 2. So I'm going to rise a negative 1 and run 2. So I'm going to rise a negative 1 and run 2. And of course, you can do that a couple times, but I told you you only need 2 points to form a line. And so there we go. And of course, always check to make sure slope is negative, it's negative, to make sure you didn't mess up and can fix something easily. Okay, find an equation of the line through the points. So in order to write an equation of the line, I always need the slope. So that's the first thing I'm going to do. And of course we reduce. And I need a point. I'm just going to pick this point. It doesn't matter which one. Okay, and there I have it in point slope form. Again, you could solve for a slope intercept by solving for y. And there's our slope intercept, y equals mx plus b, which you definitely should know where this is my slope and this is my y-intercept. Okay, find the equation of a line with slope 3 and y-intercept of 2. This I want to do in slope-intercept form. Well, if my slope's 3, that's my m, and the intercept of -2. Done. Good. Find the slope and y-intercept of the line. So this is in a different form. If we can get it in this form, then we know the slope and the y-intercept. So what I would do here is solve for y. This isn't quite in the form, we would say nx plus b. So my slope here is 2/3 and my y-intercept is 1/3. I would highly recommend that you pause these and work some of these on your own. I'm just going through them quickly with you because they're a review. You should be able to pause it, work it on your own, fast forward so you got the right answer and keep moving. X equals 3, so that's everywhere where x is 3. So x is a vertical line and y equals -2. We already talked about y is wide, but as a reminder, a horizontal line is going to be y equals some number, vertical is going to be x equals some number. Here's your general equation of a line. So, or we normally call it standard form. So ax plus by plus c equals 0. We don't use standard form a whole lot. I don't really expect you to write them in standard form often. Sometimes it's helpful to find intercepts, things like that. But it says sketch the graph of this equation. Well, in order to sketch it, we have two options. We can either plot points, which is probably everyone's least favorite option, or we can solve for y and put it in slope-intercept form. That's really what you should go with. So I'm going to solve for y. So I'm going to subtract my 2x over and add my 12. And then I need to solve for y, so I'm going to divide by 3. Of course, you can show more work if you need it, but that's what I get. Now I know my slope is 2/3, so I'm going to rise 2, run 3, and my y-intercept is -4. So on my y-axis, I'm going to go down to -4, and I'm going to rise 2 and run 3. And of course, you can do it again and again, but all we need is 2 points, and we're done. Parallel and perpendicular lines. Parallel lines have the same slope. That's this parallel symbol. They look like parallel lines. Perpendicular lines, that's the symbol. It looks like perpendicular lines. You could imagine a little right angle being there. Don't forget, perpendicular does mean they intersect to form a right angle. Their slopes are opposite reciprocals, or their product is -1. Either way, opposite reciprocals would be like opposite. Take the opposite sign. That was a positive. This is a negative, and then take the reciprocal. Also called negative reciprocal. Either way. If I have two vertical lines, they're obviously parallel. So vertical would be like maybe x equals 3 and x equals 5. Those are parallel. Horizontal lines are parallel. So y equals 2 and y equals -7. Those are parallel. And then, of course, vertical and horizontal intersect to form a right angle. So y equals 3 and x equals 7 are going to be perpendicular. Find an equation of the line through the point 5, 2 that is parallel to the line. Well, if it's going to be parallel, it's going to have the same slope. So I need to find the slope of this line. Well, to find the slope of this line, I'm going to move everything to one side and solve for y. And I'm going to reduce. And so the slope of this line is -2/3, but I want the same slope, so this is going to be the slope of my new line. This, my y-intercept, I'm not going to use that for anything. That's specific to this line, not to my new line. I'm going to have a slope of -2/3, and then I'm going to use this point. So I'm going to put it in point slope. Most of you, I think, were taught to work from put it in point slope and then get to slope intercept. I actually learned it the other way, and whatever's fine as long as you can convert between the two. And hey, this totally works. Again, if I asked you to put it in slope intercept form, which is what I'll normally need to do, or normally will do, and you'll always need to do if you're going to graph, but you can distribute and solve that. Okay. So I have 3 points, and it shows there the vertices of a right triangle. It says show. So remember, this is where my work is going to be my answer. I went ahead and plotted just roughly, this is about 3, 3, 8, 17, and 11, 5, roughly, just because I need to see where my right angle would be, and you can tell this is where my right angle should be. So I need to show that there is a right angle here, which means I need to show that PQ is perpendicular to QR. Well, how do I show they're perpendicular? I want to show that their slopes are opposite reciprocals. So I'm going to find the slope of both lines and hope they're opposite reciprocals. If so, we showed that this is a right triangle because it has a right angle. So P and Q, I'm going to do 17 minus 3 and minus 3. And QR, these two I'm going to do 5 minus 17 and 11 minus 8. Okay, so I'm working this and I'm like, this is not looking right. I realize I made a mistake because these are not perpendicular. These are not opposite reciprocals. I would need a negative 1/4 or a negative 5, sorry, a 1/4 or a negative 5/14. I don't have that. This is a problem. It said show that the points are the vertices of a right triangle. That doesn't mean like see if they are. It means show, which means they should be. So this tells me I made a mistake. So there's two things I can do now. One is, hey, my picture was really ugly. Maybe that's off. Another might be, hey, I have PQ, I have QR. Let me see if I really picked the wrong angle and let me test PR. And so PR would be okay, now that is looking better. This is perpendicular to this. Okay, so I showed it's a right angle, but that's kind of weird. That's not what I thought it was supposed to be at first. And that's really just because I drew a bad picture. So if I come here, which I was going to erase this and redo this, but like redo this part of the video, but I was like, well, I guess this is a good lesson for us to learn. Neatness does count. So if I got 3, 3, there's P. So this is still not really accurate, but it's a little bit better. When I graph it more accurately, you can see, oh, well, that was a bad line, but you can see, oh yeah, it totally makes sense that here's the right angle. And that's what we just proved. So it's actually PR and QR I was looking for. Oh no. So yes, we proved they are opposite reciprocals because we showed PR is perpendicular to QR because their slopes are opposite PR and QR. So that was my mistake, but that shows it's important to be neat, which I'm bad at. So opposite reciprocals, so they're perpendicular, so we have a right triangle. Example 9. Find an equation of a line that is perpendicular to this and passes through the origin. So the point I'm going to use is 0, 0, but I need to get the slope from here. So I'm going to solve for y. I'm just doing this off the top of my head, so I know some of it's taking me a while. I'm not as good at mental math as a lot of you are. So here's my slope, but I want something perpendicular to that. So my slope is actually going to be 3/2, and then I'm going to use this point. So I'm going to say y minus 0 equals 3/2 x minus 0, or of course you said y equals nx. And what's my intercept? Well, it goes through the origin. Either way, you reduce, and do reduce. Do not leave this for me, because y minus 0 is y, x minus 0 is 0, and you get this. Okay, we have 3 examples left and only 20 seconds left on this video. We're not going to finish, so stop it, and then you'll have another short video to watch.